Hello everyone. So today I'm going to explain about split brain protection in Hazelcast. First of all, we need to understand what split brain problem is. So in case of Hazelcast, let's say you have created a cluster of 10 nodes and you have deployed that cluster. So initially there are 10 nodes in that cluster, but due to some network failure or due to some network latency, there could be a situation in which the cluster splits into two parts. So that splitting of a single cluster into two or more than two parts is called split brain problem or split brain syndrome. For example, let's just consider that the cluster gets split into two clusters, and one cluster consists of 6 members and the other cluster consists of 4 members. So this is called split brain problem. The problem that is going to happen in this case is if a client is trying to connect to the cluster, Hazelcast cluster, to get some data. In that case, there could be a possibility that the client either may get connected to cluster of size 6, or he may get connected to a cluster of size 4. Let's just name the two clusters: cluster A, which is of size 6, and the cluster B, which is of size 4. So let's say client uh, requests for some data, and for that it gets connected to cluster A. So what happens, he will just fetch some data from cluster A, and the client will make some updations on that data and store the data again in cluster A. Okay, so this is what happens in first case. Now again, after sometimes the same client requests for some other data, but this time the client gets connected to cluster B. Okay, so what will happen, whenever the client will fetch the data, the client will see some inconsistency in data, because in the first request client has uh, made some updations to a data, and but he is not able to see the same updations in the second request. So this is a data inconsistency problem. Now why this data inconsistency problem happens, because Hazelcast is a distributed environment, and all the data structure that we create in Hazelcast are distributed among all the nodes in a cluster. So let's say since there were 10 nodes in the Hazelcast cluster. So now if a map was created initially, so the all the entries which are present inside the map will be distributed among all the nodes in the cluster, all the 10 nodes, and also the backups of the map would also be distributed. So that's why some of the entries so that's why after the cluster is split into two parts, so some of the data and its backup would be present in one cluster, and some of the data and its backup would be present in other cluster. But after the cluster split, the client initially made updations in one cluster which will not get propagated to other cluster, because there is a network failure and the two clusters would not be able to synchronize data between them. So this is called split brain problem, and there could be a problem of data inconsistency. So to protect the client from getting inconsistent data, we have a functionality in Hazelcast, that is split brain protection. So there are two ways in which we can apply this split brain protection in case of Hazelcast. The first one is member count quorum, the second one is probabilistic quorum function, and the third one is recently active quorum function. There is one fourth method, that is custom quorum function. You can create your own quorum function and you can just protect your clients from getting the inconsistent data, or even you can protect your data in the cluster to get updated so that it doesn't get inconsistent. So right now, today I'm going to talk about quorum, member count quorum function, member count quorum, the first way to implement split brain protection. I'll be making a program in which I'll show you how to implement member count quorum. So first of all, you need to understand what quorum is. Quorum is nothing but you can take it as a threshold number of members that has to be present in a cluster in order to make all the operations in the cluster functional. Let's say initially I have created a cluster of size 10, and initially I define that the quorum size is 6. So quorum size is 6 means whenever there is a split in this cluster, as long as there are 6 members in the cluster, in each of the cluster, till then all the operations on the data structure, you have the power to choose whether you just want to block read operation, or you just want to block write operation, or you just want to block, or you want to block both read and write operations. By default, both read and write operations on data structures are blocked in case of split brain protection. I will show you the example, then I think you will be able to understand it more properly. So quorum is like a threshold. Whenever the size of the cluster is less than the quorum size, in that case the operations, either update operations, either write operations or read operations, or both, could be blocked on the data structures and its entries, just to ensure that the client which is connecting to the cluster is not getting inconsistent data, or there could not be any inconsistency in data. Now let me just show you an example. So today I'll be creating a program to show you member count quorum, how we can use member count quorum to implement split brain protection. And also this quorum split brain protection is specific to data structure. Okay, let me just first write the program, then I think you will be able to understand it properly. First of all, I'll create an object of quorum config. I'll set the name of this quorum. So right now in this example, I'm going to create a quorum size of 2. So let me just name the quorum also like that, so that it will be easy to understand. I just named my quorum, I enabled it, and I set the size of the quorum to 2. Now so this is the quorum that I have created, quorum object that I have created. Now I will apply this quorum config object to my map data structure. One more thing, before creating map, there is also what type of quorum do you want to create? You just want to create a quorum to block read operation, or you want to create a quorum which would block read and write both operations on the data present in the map, or you just want to create a quorum which would block only write operation on the data structure to which this quorum has been applied. By default, the type of the quorum is read write. So right now I'll choose write. Only the write operation on the map data structure would be blocked by this quorum. So now I'll create one map config. I'll give the name of my map to which this map config should be applied is my map. I'll set quorum name as 2 nodes quorum, right? So I've created a map config object for my map whose name is my map, and I've applied this quorum to my map data structure. Now what I'll do, I'll just create a config object. Now with the help of this config object, I will create one Hazelcast. Now my Hazelcast instance has been created. Also, initially because I have created a quorum of size 2. That means only when there are at least 2 nodes in my cluster, then only all the write operations in this map would be possible. Otherwise, we will be getting some quorum exception. So we will have to create 2 nodes in our cluster. So let's just create one more instance of Hazelcast. Now I'll just create a map. Right now I have created 2 instances of Hazelcast. So right now we have 2 nodes in our cluster. As I told you earlier, as long as the size of the cluster is equal to the quorum size, till then all the operations on that data structure would be possible. So since till now we have 2 nodes, so I'll just try to put some data in the map. So this insertion of data in map would be possible because it is satisfying, because right now the cluster is satisfying the threshold, that is it has at least 2 nodes. So this operation would be successful. Now what I'll do, initially I inserted one of the data in a map, then I'm shutting down the second instance of Hazelcast. So what will happen, the second node in our cluster will be closed, and then our cluster will have only one node. So since our cluster is having only one node, So now all the write operations on our map would not be possible, and it will throw an exception, quorum exception. So let me just show you. As soon as the member is shut down, so it will take Hazelcast to actually, it will take the first instance to actually know that the second instance is dead and the cluster is now having only one member. So that is why we will have to stop the execution of the current thread. So that's why I have written this thread dot sleep. Now after waiting for some time, I will again try to put data in a map. So this statement here, map.set, will not get executed, and it will throw an exception. Yeah, let's run the program. So see, we have got an exception that is quorum, that is of type quorum exception, and it says that split brain protection exception 2 nodes quorum has failed. So the quorum, this is our quorum name. So this has failed and it has not been satisfied. Let me just scroll up and show you how exactly it was done. So initially when we had ran our program, so initially the first Hazelcast instance was created. This was, so that time the size was 1. Then after some time the second instance was created and it also joined the first member, so a cluster of 2 members was formed. Now we had inserted one value, so we are not printing, we have not given a print statement, so that's why it's not visible in the console. But there are also no such exception, right? So we'll just scroll down, and again you can see Hazelcast shutdown. So since we are shutting down one of the instance of a Hazelcast, so here in the logs you can see that one of the instance was shut down, and since there was a shutdown, so the first instance is unable to connect to the second instance, so there is a socket exception as well. And finally after some time Hazelcast first node came to figure out that it only has one member in the cluster now. So now since our cluster quorum size was 2, the size of a cluster is less than the quorum size. So in this case all the write operations on our map, my map, would be blocked whenever any client is trying to make any write on the map entries. In that case he will get a quorum exception, and this is the quorum exception. Okay, now since our try block was not executed, we got an exception in the catch block, so this entry was not inserted into the map. So this is how, whenever there is a split brain problem, we could keep our data consistent, and we could stop our client from making either any updation or any new insertion in our data structure. So right now in our program, I'm just inserting a new value or a new record in a map, but this quorum would also be applicable to any updation. Let's say let's say in place of setting test